Hey everybody, today it's going to be 1.6 angles and their measures. There are going to be several vocabulary words, but good news is today is going to be the last day of chapter 1 and we will move on from here. Okay, today we're measure and classifying angles and adding angle measures together. Vocabulary. Here we go. First three words are going to be angle, sides of the angle, and vertex. Take a moment now. Pause. Please write this down. All right. Very quickly. I know you have heard of the term angle before. Just know that it consists of two rays with the same endpoint. So if I gave you this, we have a ray right there. We have a ray up there. They are connected by one single endpoint being there. That endpoint is going to be known as your vertex of the angle. The rays that I just drew right there is going to be your sides of the angle. So the rays are the sides, the vertex is the endpoint. Okay, moving on, last two, pause now, write it down. All right, the measure of an angle is written in units called degrees. If I ever write down something like this, 93, and I'm talking about a 93-degree angle, I need to make sure that is going to be written in units as well with that degree symbol. Okay, it's just like writing miles after a word problem, minutes, miles per hour, that type of thing. Make sure you have your degree symbol when using and talking about measurements of angles. Congruent angles. The word congruent, that means same measure. Same. Congruent, same, congruent. Two angles are congruent if they have the exact same measure. So if I give you this angle right here that is 30 degrees, and I tell you this angle right here is also 30 degrees, these two angles are what known as congruent angles. They are the exact same. Ooh, forgot my little degree symbol. Don't forget about those. All right, I think you have heard of these before. Please write them down, the four types of angle. Okay, acute, right, obtuse, straight. All right, when we talk about acute angle, that is the measure is 0, greater than 0 and less than 90. So if it's 0.111, that is greater than 0, that is an acute angle. 0.111 degree is going to be an acute angle. If it's 89.999, that is also an acute angle because we're not quite at 90 degrees. At any point does an angle turn 90 degrees, it is known as a right angle. Okay? When it is a right angle, you will notice that little box there. That is meaning the measure of 90 degrees. Measure of 90 degrees is that little red box in that corner. If you ever see that, know that it is a right angle. Obtuse. An obtuse angle is greater than 90 degrees, so 90.1, 90.01. Those are greater than 90 degrees. Those are obtuse angles, all the way to less than 180 degrees. If at any point an obtuse angle turns 180 degrees, it is no longer an obtuse angle. It turns into a straight angle, basically being opposite rays going from left to right. All right? It always measures, there's supposed to be an S in there, measures 180 degrees. You don't have to write this down because there's no yellow bar. I'm just going to show you how you name an angle. It says a surveyor recorded the angles formed by a transit, which is point A, right here, and three distant points, B, C, and D. Name three angles. The very first thing we have to do when we're naming angles, we need an angle symbol. And it looks just like that. Just like a line above AB means line segment AB, that symbol means angle. Okay? Whenever we're naming angles, I'm going to start with one point, and I'm just going to move across. So I'm going to write BAC. That is angle BAC. Notice that my vertex is always going to be in the middle. A is going to be my vertex on each of these angles. It will always, always, always be in the middle. Another way to rewrite BAC, the naming of CAB is also the exact same angle measure. All right? So angle BAC and angle CAB are the exact same angles. Notice, again, vertex in the middle. Few other angles. Angle CAD, which is also could be called angle DAC. Lastly, angle BAD or angle DAB. Again, each of these have a vertex in the middle. All of these have the vertex of A. They are all in the middle. Also, we will have the angle sign on each of these right there. On the end, right before you start, we have angle symbols. Now, there are some times where you can classify an angle as just by the vertex, angle A. However, in this drawing, that is impossible because this could mean, angle A could mean BAC, could mean CAD, or it could mean BAD. So we cannot just draw it by the vertex because there's more than one angle. We'll get to an angle later on that we can do that, and I will show you that. Please write this down. You do not need to write that protractor. I just want you to write the lines here, similar to that, and try to classify them as an acute, right, or obtuse. All right, so BOA, that's supposed to be an angle symbol, not a square symbol. BOA, if I look at this, I'm just going to erase this so I can see BOA. I'm going to look at it. I'm going to retrace. BOA, notice vertex is in the middle. BOA, when I look at that, I'm going to find the measure. It crosses because it's pointing to the right, always pointing to the right. I'm going to use the underneath numbers. Underneath numbers. Pointing to the right, underneath numbers, it looks like it covers at 40 degrees. We know that a 40-degree angle is always less than 90, which means it is acute. It's so cute because it's so small. It's acute. Okay, acute angle. Next, EOC. All right, erase these lines right here. EOC. Now, we're pointing to the left this time, so I'm going to use my outside numbers. If I use my outside numbers, it looks like that red line goes through 105 degrees. It is greater than 90 degrees. So what happens when an angle is greater than 90 degrees? You are correct when you say right angle. Or sorry, not right angle. What am I doing? It is an obtuse angle. Obtuse is greater than 90 degrees. I got caught up on that 90. Obtuse is greater than 90 degrees, so an 105-degree angle is obtuse. Don't have to write this one down. I'm just going to show you. You're going to write one similar on the next slide. So, naming the vertex. Sides of the angles, estimate the measure. I'm just going to take a guess and then write two names for the angles. Vertex. I'm looking where my endpoint of those two rays are going to be. That is at point B. They come together at point B right there. Okay, sides. Those are my rays. It's going to be ray AB, ray. Sorry, not ray AB. Ray BA. Make sure you start with that vertex. I almost made a mistake there. And also ray BC. Endpoint is always going to be your starting point on a ray. Lastly, second to last, estimate the measure. If I'm looking at that measure, I'm just going to guess roughly 30 degrees, which makes it, if it's 30-degree angle, what is it? Acute, right, obtuse, or straight? Acute, I hope you were thinking. Two names for the angle. I could write angle ABC or angle CBA. Another one, a third one that we could actually write, because this is only one angle, we could name it by its vertex of angle B. So all of these could be three possible names. I know it says just two, but you can actually name three. Try that same thing on this one. These are supposed to be rays that are going on forever. Okay, it says name the vertex, the sides, estimate the angle, and write the two names. Give this a shot. All right, so vertex. When I look at my vertex, those two rays coming together at point H. All right, sides. When I look at these sides, I'm looking at my two rays, ray HG and ray HI. Again, I made those two rays starting with my endpoint. Estimate the measure. If I'm looking at that, I'm just going to take a guess. Roughly maybe 120 degrees. Okay. 2 names for the angle. You can name 3. If you know the 3, awesome. Let's see if you got the 2. Angle, GHI. Angle, IHG. Or angle H would also work. Angle H. All right, moving on. All right, we are going to learn one postulate today. It says, this is the angle addition postulate. Please write this down, pause, and then I'll explain. All right, it says, if S is in the interior of PQR, then the measure, that little M right there, on each of these mean measure. The measure of angle PQS plus the measure of angle SQR is equal to the measure of PQR. What is this talking about? That means if we take this angle, this inside angle right here, remember S, this point, has to be inside PQR. But if we look at this measure PQS, SQR, this angle plus PQS, which is this black one, we add those 2 measures together, we get the entire angle of here. Okay, add that blue section with that black section, and you should get that red section, the angle addition postulate. Let's try one. All right, I want you to pause this after you write it. Give this one a shot. See how you do. All those squares are supposed to be angle symbols, not squares. All right, so the measure of angle DEG is equal to 115. DEF is 48. FEG, we got to find. All right, so the very first thing is I'm going to set up an equation. When I set up the equation, according to the angle addition postulate, angle, the measure of angle DEF plus the measure of angle FEG is equal to the measure of angle DEG. All right, I'm going to plug these numbers in. What I know, DEF is 48, so I have 48. FEG, I'm trying to find FEG, so I don't know. Plus X, and DEG we know is 115 degrees. Okay, we solve this like we would a normal problem. Okay, one-step equation. We need to take 48 out on both sides. We have X here. 115 minus 48 degrees. You have 67. Don't forget your degree symbol. Without that degree symbol, it is incorrect. We are talking about angles. Make sure we know we are talking about angles by putting that degree symbol in there. All right, that's all I have for you today. You have finished up chapter 1. Let's get going.